All right, well, I will begin with a word of prayer. So get up here. Heavenly Father, we thank you for this day. Again, I thank you for these students. Just ask you bless our time together. Help us to glorify you what we do, and just to answer any remaining questions about this material, Lord. In your name I pray, Lord Jesus. Amen. So if you don't mind, I'll collect your quizzes. So we got one more quiz to go, right? Yeah, there's one more quiz. It's Tuesday. In class. All right, everybody?
You can go, sir.
Mm-hmm. You already gave me. Cool. Thank you, thank you. Thank you. All right. Oh, you passed it right there? Okay, cool. All right, that's it. All right. Very good. Let's start by looking at the solution to this thing. All right, see if I can get it here. All right, so first of all, simplify the following expression into a single logarithm. So basically, I have plus 17, log of 17 plus log of x plus 2. So those go together in the numerator, 17 times x plus 2. And then since I have a minus 3, that 3 becomes a z plus 8 cubed. And since it's a minus, it divides by. So that's problem 1. Let's see here. Problem 2, simplify this expression by expanding. So I have log of x cubed plus the log of e to the 2 times x minus 3 minus the log of x plus 7. And then since the natural log and the exponential are inverse functions, that just gives me back 2 times x minus 3 here. And then I have that. So that's the answer there. Excuse me. The graph, the easiest way to think about the graph is just you take the y equals 3 to the x graph and you shift it up 2. That's how you do that. This one is just the natural log graph shifted 6 units to the left. So like this point right here would actually be minus 5, 0. If you just have y equals log x, that point is 1, 0, like it's over there, right? So it gets moved 6 units to the left like that. There's the y equals log x has a vertical asymptote at y equals just the y-axis, whereas this has a vertical asymptote at x equals to minus 6, like that.
Did you want us to draw a vertical horizontal asymptotes?
No, I mean, if you didn't draw the asymptotes, it would be okay. It still might be right. Kind of depends on, how sketchy it is.
What if we
I don't know.
didn't draw the horizontal asymptotes and we got it wrong?
Well, there's that. This one here, it said find the time at which a of t is equal to 6. So to solve this, you put a of t, which is this, equal to 6, which is 6. So 6 equals to this. Subtract 5 to the other side, divide by 2. That gives us 1/2 is equal to e to the minus 0.3t. Then I take the natural log of both sides, like so. And that gets me minus 0.3t over here, because these are inverse functions. And then I solve for t, which gives me the quotient of the log of 1/2 and minus 0.3, which my calculator gave me about 2.310 for. So, yep.
I got the same number, but like my path to get there was a little different.
Uh-huh.
Would I still get credit for it?
Oh yeah. There may be another way to do this. Did you take you have like natural log of 1 equal to 2 times e to the minus 0.3?
I think I might have just written the log of 1/2 divided by 0.3. I think I did 1/3 the log of 1/2.
Oh.
I think.
Huh. I mean, yeah, there's various, as long as we've got the same number, I think we agree. Yes, sir?
I put 2.31 instead of 2.310.
Yeah, that's fine. I wouldn't fault you. Excuse me. 2 to the x equals to 5. So I take the natural log of both sides, and after I do that, I pull the x out by the power property. That gives me x log 2 equals log 5. I divide by log 2 both sides. I get log 5 over log 2 is x, which is about 2.32. Which is kind of funny, because wasn't that the last answer?
Yeah.
That's a coincidence, isn't it? I mean, that's total coincidence. I just think it's funny. Sorry. I'm easily amused. Problem 6. Any questions? No? Problem 6. Here we have the log plus the log equals to the log. Here x minus 1, x plus 1. So I use properties of logs to rewrite that as log of x minus 1 times x plus 1 equals the log of 3. And then by the one-to-one property of the log, we have that the input to the log on the left-hand side is equal to the input of the log on the right-hand side. Of course, the other way to see this would just be to exponentiate both sides. However you want to look at it, we get to x minus 1 times x plus 1 equals to 3. Multiply that out, I get x squared minus 1 equals to 3, which is x squared minus 4 equal to 0, which factors to x plus 2 times x minus 2. So either we have x equals minus 2 or x equals 2. But x equals minus 2 we have to throw out. Those are extraneous. If we go back and look at our original problem, we can't plug minus 2 into this formula because it gives us a log of minus 3 and a log of minus 1, neither of which are real numbers, right? So whenever we have a problem like this, use properties of logs. It's important to check your answer back at the start and make sure that you're not, saying something is an answer that's not actually an answer. 2, on the other hand, is just fine because 2 minus 1 is 1, and 2 plus 1 is 3, and so it works. Yes, sir?
It's better to simplify there rather than adding for the other side and square root, because you missed the option of the other, like minus 2. Like,
Well, if you did the square root, though, you should include plus or minus the square root.
right.
So you'd still have the same, what I'm saying is, if I understand what you're saying correctly, if I was to look at, if I had instead looked at it, okay, I've got x squared equals to 4, right? Then I should say x is equal to plus or minus the square root of 4, which is plus or minus 2. See, so I'd still get the same solution set if I use square root. And if you miss the minus, well, that's a fortunate thing, right? Because you've just not lost a solution either. And, I probably shouldn't take points off because who am I to say that, you're not doing it out of commission versus omission or something. I don't know what you would say. Problem 7. Oh, you have your quiz?
I was not here Tuesday.
Oh, but it was by announcement in Canvas. But anyway, so see, this is the problem with Canvas announcements not being emailed to everybody, and why you should turn on the announcements. By the way. Oh well. So let's see here. So this one, we have e to the x squared minus 3 e to the x minus 4 equal to 0, if I rewrite this, right? And so then I want to look at it as a substitution, basically, like an e to the x substitution. See, because then I have a quadratic in e to the x, which I can factor. And when I do that, I either get e to the x equal to minus 1, or e to the x equals to 4. Now, e to the x equals to minus 1 is impossible to solve. The exponential always takes positive values. There's no way you can get minus 1 out of an exponential. So that has no solutions. On the other hand, this one, if I take the natural log of both sides, I get log of 4 is equal to x, and that's the solution. So if you were to try the same thing over here, you'd have x equals to the log of minus 1, and then your calculator would kindly inform you that you can't do that, Or if you're unfortunate, you wouldn't pick up the calculator, you'd just write natural log of minus 1 like it means something, and then I'd have to take points away from you. Which would be sad, because I already have enough points, and I really don't want any more. So please keep your points. So that's that for this quiz. Any questions about anything? Any questions about the mission? If I can find it.
Specific mission questions? Or
Sure. Yeah, you can ask me a specific mission question if you want. Yeah.
Talk about the
Number 1?
101.
101.
That's the exact one I was going to ask.
Ah. All right, let's look at this thing.
Also, 1 and 2 is the ones in the quiz.
What's that?
1 and 2 is the ones in the quiz.
Oh, really? Oh, man.
There's another one that's only quiz 2.
Oh, what did I do? Don't tell everybody.
I won't.
Okay, thank you. Let's see here. It's almost like I'm repeating problems to emphasize that they're important and that you should make sure you know how to do these kind of problems. All right, let's see here.
Between us, problem 99 is on the quiz 2.
So those should be relatively easy to make sure you get right, right? Yeah, okay. So how about this one? I gotta step back here for a minute. I can't read it. I need to be further away from it to appreciate it. But not so far away I can't read it either. It's a balance for me. Man, I need glasses. So Newton's law of cooling describes how temperature of an object changes as it gains or loses energy. All right, so a hot cup of coffee loses energy as it cools to room temperature. A cold can of soda gains energy to warm to room temperature. The formula for the temperature of the object is given by that. Y of t is the r plus a e to the minus t, where r, stupid cursor, there we go, where r, a, k are constants, k is positive, and r is the ambient or room temperature. Suppose we have a cup of coffee initially heated to 150 degrees Fahrenheit, and after 10 minutes it cools to 120 degrees, and the room temperature is 70 degrees. Find the time at when the coffee cools to 80 degrees Fahrenheit. All right, so we can work this problem, you know, like one step at a time. Like our formula is y of t, right, equal to, what do we got here? R plus a. What's that? A chalice, did you say? I mean, if it's not too annoying, we could just make it a big T. Temperature, right? But then understand big T and little t are different. If we're good on that, then we can use that notation. If that's okay with you guys. Thank you. I just gotta mess with it a bit. All right, so what do we know? I told us what? I told us the room temperature is 70 degrees, right? And so what does that mean? We have the room temperature is 70 degrees. That means R is 70 degrees. So we know that. All right, what else do we know? We know initially, right? So when you see the word initially, you should think t equals to 0. So at t equals to 0, we have 150, right? So t 150 equals to t of 0, which is what? That's 70 plus a times e to the minus k times 0. So can you guys simplify that? Let's rewrite that equation. This whole equation here, let's rewrite it again. What is e to the 0? Well, I can subtract 70 to the other side, right? So I've got 80 is equal to a. What's e to the 0? Fine, I'll make another. So you've got 150 is equal to 70 plus just a, right? Because e to the 0 is 1. So what's a equal to apparently? Yeah, a is equal to 150 minus 70. A is equal to 80. All right. Okay, so what do we know? Let's regroup. We know that c of t, right, is equal to 70 plus 80 e to the minus kt. Now we don't know what the k is yet, do we? But do we have more information? Sad. That was not optimal. And the rule is like if you can catch the marker I throw at you, then you get like 10 points or something. But the catch is that I could throw the marker at any time, you know? No. Did I get it? Ah! All right. Well, there he goes. All right, I think I should just end the semester here. Class is dismissed. No, I'm just kidding. All right, so what do we need? What have I not used yet? Oh, after 10 minutes, the coffee cools to 120, right? So I also know, yeah, T of 10, 120 is T of 10, right? That means I plug 10 in for T. So that's 70 plus 80 e to the minus k times 10. All right? Now let's simplify that equation. Right? Because we would like to figure out what k is. Right? That's the last remaining puzzle piece here in terms of completely owning the temperature function. So 120 minus 70 is 50. 50 is equal to 80 times e to the minus 10k. Right? And then if we divide both sides by 80, what do we get? We get like 5/8 is equal to e to the minus 10k. How do I solve for k? Yeah, take the natural log of both sides. What do we get? Bless you. Natural log of 5/8 is the natural log of e to the minus 10k, also known as minus 10k. So k, apparently, is equal to minus 1 over 10 natural log of 5 over 8. All right, great. And because it doesn't give me great joy to write that, I'm going to approximate that to a few decimal places for our purposes, if that's okay with you guys. Actually, even if it's not okay with you guys, I'm still going to do it. Sorry, it's true. Natural log of 5 divided by 8 is about 0.47 with a negative. I divide that by 10. I get minus 0.047 and then a bunch of zeros, actually. So that's pretty good. All right, so put this all together. What have we learned? Where are we? Well, now we have a formula, right? We have a formula for the temperature time t. So now I have, my formula is this, T of t. Put it all together. 70 plus 80 e to the minus kt. What? Wait a minute. Oh, this is just a calculator mistake. It's plus 0.047 here, okay? I put the minus in the formula, so it's minus 0.047 t, where t is in minutes, all right? Okay, so now we've come this far. What's the question ask us? Find the time at which the coffee cools to 80 degrees Fahrenheit. All right. So now what do we need to do? I heard, yeah, set t of t equal to, set t of t equals to 80, right. Which is to say set 70 plus 80 e to the minus 0.047t equal to 80. So this gives us 80 e to the minus 0.047t equals to 10, which gives us e to the minus 0.047t equal to 1/8. Does this make sense, guys? Or follow me? Right. Now, how do I solve? I mean, how do I solve for t? I need to do what? I need to take the natural log of both sides, right? So if I take the natural log of both sides, I get the natural log of e to the minus 0.047 times the time I don't know is the natural log of 1/8. And that gives me minus 0.047t is the natural log of 1/8. So solving for t, I get t is equal to the natural log of 1/8 divided by minus 0.047. This problem is like 5 other homework problems all rolled into one, isn't it? Yeah. Like whenever I ask one of these on differential equations test, I have to allot like 10 minutes for it, you know? It takes a while to sort through all this. And what I got here, according to my calculator, is 44.24. Did you guys get that? Anybody? Well, I make the exam, so, you know, it takes as long as it takes, I guess. But, oh, it's about twice as long, I would say. So, yeah. I mean, maybe not quite twice as long because you guys have the 75 minutes, so, you know, I don't know. If we were in a Monday, Wednesday, Friday class, I would just tell you it's twice as long. But it's probably about 8 to 10 pages. It has everything on it, you know, something like that. Yeah.
Can we look at 103 and maybe 104?
Problem 103? Sure. Let's see here.
Are we just solving?
Just a second, let me. So we've got 2 to the x. 2 to the x equals 3 to the kx. The question is how to solve for what?
It says find a constant k for which that for every x.
Ah. Okay. So basically you could say find k such that this is an identity. So an identity is something that's true for all x. Any ideas? Take the natural log of both sides of the equation. I like that. What happens if we do that? We get this, right? Then how does that simplify? Well, hold on a second. How does, I mean, we took the natural log of the equation. What comes next? You might be telling me the answer, and you might be right, but how do I go from there? Remember the property? We have log of like a to the power p. We have p times log a, right? So I can use that on both sides. I have x times log 2, right? And I have, get out of there. X times log 2 is equal to kx times log 3. So you can, since it has to hold for all x, we can cancel the x's.
And then divide both sides by log 3.
Right, so k equals to log 2 divided by log 3. Yeah. Yep. I'm sorry, I seem to have solved your homework problem. You'll forgive me. Of course, the fact that there's course evaluations right now has nothing to do with me solving the problems in class. Completely unconnected event. Just saying. So let's see here. Problem 10, we did problem 104? Yeah. Listen, I want you all to have a perfect score on the homework. I want you to understand the homework. So if I do the problem, it's only worthwhile to you if you understand what I'm doing. If you just copy this solution I'm writing on the board down like you understand it when you don't, you're still going to do bad on the final, right? So like, if you don't understand what I'm doing, you need to like speak up, all right? Oh, this one I'm not going to remember. Yep.
Where does x go in 103?
So here we can divide by x. See, if this has to hold for all x, in particular, it has to be true when x is equal to 1. So if you want, we could say, you know, set x equals to 1 if you like, because if it's true for all x, it's true for x equal to 1. And if it's true for x equal to 1, then that gives us log 2 is equal to k log 3, which we solve for k. Yeah. Let's see here. The logic here is different than when we're solving an equation and when like we divided by x, we lost things, right? Because we didn't know it was an identity. We weren't given it was an identity. We were like solving an equation. It's a different context. 104? Do you guys know 104? So here we have p of t is equal to 10 e to the, and also don't trust me, I'm sick. So like I could do stuff in here that's totally nonsense.
Is that a self-compliment when you were sick?
Yes, sure, yeah, that was, I'm sorry, I'm still struggling. I'm working on my humility. Sometimes these sorts of things come out of me, but, you know, I'm proud of how much I've, you know, accomplished so far in battling my lack of humility, but, you know, still working on it. Let's see here. That's the kind of fun thing to put in a self-evaluation, like a yearly self-evaluation. Like, I'm much more humble this year than I was last year. You know, it's like,
Dare I say, I may be the most humble professor on.
what is it? I'm a million times more humble than thou art. Let's see here. Let's see here. Let's see here. Churn in lots of butter. How's it go? Let's see here. 1/2. Oh, what the what? T over tau. All right. What is the value of tau? All right, so this problem is about the problem of finding the half-life, if you will, or the halving time. See, and then you're supposed to find tau, and then I think it says find what? P of tau, P of 2 tau, right? All right. So how do you figure out what this tau is? Kind of like the last one, we just have to put what we're given equal to what we have, what we're trying to find, right? So like, to make progress here, Either you need to make an incredibly like creative leap and just see it, which is possible, or you let the algebra do the work for you. I suggest we let the algebra do the work for us. E to the minus 2t is equal to 10 times 1/2 t over tau. What did I do?
It's not you. It's an emergency, but I'll be back.
What could be more important than college algebra? Her mom?
Do you not think your mom is important?
I don't mind.
I know why I think that should your mom.
Fine, yes, my mom's important. Game, set, match. Very nice. All right. Okay, so call my mom right now and apologize. Well played. Let's see here. All right, so how do I make progress on this beast? Well, one thing I can do, divide by 10. Yeah, that makes it nicer. E to the minus 2t is equal to, and we could write that as 2. Well, I'll leave it as 1/2, fine. I mean, I don't know. We could write this as 2 to the minus t over tau if you wanted. That might not be a bad thing to do. This last step I made is, I don't know, I'm not completely sold on it. I'm not sure it's helpful to you guys. Now what do I do?
I make my tau with z, so I don't confuse it with the t.
Yeah, you can make your tau whatever you want. You can make it a. If you have a duck that you like to use as a variable, sure. Just make sure that your variable is not a number or a variable you're already using. Okay. Anyway, so I think what we should do, and listen, I'm kind of like not liking this last step I made because I think you guys aren't going to make that step naturally on the test. So let's not do that. What can I do? Right. Take the log both sides. So if I take the natural log of e to the minus 2t, what do I get? Natural log of 1/2 to the t over tau. So that on the left-hand side, I've got minus 2t, right? On the right-hand side, I've got, well, natural log of 1/2 raised to the power t over tau. Now what can I do here? Well, I can use the power property of the log again, right? I can pull t over tau out, right? So I've got t over tau, which I don't know, natural log of 1/2. Just like the last problem, this is an identity. It has to hold for not one time, but all time, right? So we can put t equals to 1 if you like. Set t equals to 1, get rid of the t, and we're almost done, right? Well, not really, but so set t equal to 1. In fact, you could have put t equals to 1 at the start of all this if you wanted to. Whatever. I mean, that would have been smart. Actually, would have been like much smarter to just put t equal to -1 at the start of all this. Then we could have solved it faster. But oh well. Anyway, the point is the t's cancel. What do we got? We've got -2 is equal to 1 over tau, natural log of 1/2. So this gives me tau is equal to -1/2, natural log of 1/2, which I could rewrite as the log of 2 over 2. I kind of like that more. Listen, log of 1/2 is equal to minus log 2. Do you guys understand that? Log of 1/2 is the log, bless you, 2 to the -1 power, right? Which is minus the log of 2. So I can pull, I have a minus here. That minus cancels with the minus there, and I get log of 2 over 2 is my tau. Okay, now, great. Let me, did you guys move the camera over here? Yeah, cool. All right. Because this right here is minus the log of 2. so the minuses cancel. All right, so I need to kind of erase the start of, can I erase the start of my algebra here? Yeah. All right. So what have we found? We found that tau equals to that, so I can rewrite my P of t as equal to 10 times 1/2 to the t divided by tau. Let me just do it over here just to make it bigger. What's t over tau look like? It's t divided by the natural log of 2 divided by 2, right? So that's 2t over log 2, actually. So I have 2t divided by the natural log of 2. I guess the question, I've lost track of what my question was. My question was to find tau, right? So we did that, right? What the value of tau is that. We can figure out numerically that too, right? So tau was natural log of 2 divided by 2. So tau is about 0.3466 approximately. All right. Now, what are we going to get if we put P of tau? Now, there's two different ways we could go here. And man, well, this is one way. Well, that's not wrong. It's fine. It's fine. My point is, it's actually in your best interest to not put like the number in, rather instead think about this symbolically. Like, what happens when I put tau into my 1/2 to the t over tau formula? What do we get? I got 10 1/2 to the tau over tau. What's that? That's, yeah, 10 times 1/2, right? Which is 5, right? What's P of 2 tau? 10 times 1/2 to the 2 tau over tau, right? Which is 10 times 1/2 squared. What's that? It's 1/2 of 5, right? It's 2.5. By the way, the question didn't ask for this, but what was P of 0? What happens if you plug 0 into the formula? You get what? You get 10, right? So what we're looking at is like a population that's decaying, or it could be like radioactive decay, for example. You have 10 of the thing to start with. After, 1 half-life, you have 5 of the thing. After 2 half-lives, you have half of you have 2.5 of the thing, and every time you go one more time tau past, if you increase the time by another half-life, you half it. So tau is the half-life of this problem. That's what it's called. Yeah.
In this situation, would it be in any way beneficial to do the like P of tau and P of 2 tau first, just because the
Oh yeah.
Value of tau is that.
Well, I mean, you can calculate P of tau and P of 2 tau without knowing tau. That's the funny thing. How can I say, this algebra we went through, we figured out that tau was the natural log of 2 over 2. Like, you could imagine a different problem, guys. So hypothetically, imagine you had P of t is equal to like P0 e to the minus kt. if you rewrite this as like p0 times 1/2 to the t over tau, then tau will be equal to, by essentially the same algebra we just went through, tau will be equal to the natural log of 2 divided by k. So like this is how this problem generalizes and how you might run into it in like a science class. Because you might want to know the half-life of something versus, you know, like the decay rate is k. All right, that's the so-called decay rate, which is related to the halving time according to this formula, natural log of 2 divided by k. And there's another trick you could do if you're interested, and you may or may not be. But if you want, you could take e to the minus kt like this, right? And if you have a little bit of imagination, you can rewrite that as a power of 2, like so. 2. Well, let's rewrite this as 1 over e to the kt. There we go. Do that to start with. And then if you really use your imagination, you can see that's 1 over 2 to the 2 to the log base 2 of e to the kt, which is, you know, equal to 1/2 to the power kt log base 2 of e, which is, by the way, equal to 1/2 times t times t times k natural log of e over the natural log of 2, which, by the way, is equal to 1/2 t divided by the natural log of 2 divided by k. So you can see from this that tau is equal to the natural log of 2 over k. So like here's a way to derive this in general by just symbol pushing. But I think the way we derived it is better for you guys, because this kind of magical inserting identities and doing weird algebra probably is not the way for you to do it, right? But there's a time in my life I got excited about figuring out how to do this, so there it is. I don't recommend you do the thing in blue unless you're interested, but it's another way of thinking. Do you guys have another question before I waste your time?
Yeah, actually,
Go for it.
domains of like logs and stuff. So
Oh, great question. Great question. Let's look at some logs and let's calculate some inverse functions, yeah? And let's talk about domain and range for those. That's probably a good use of our time. So let me make some up. I'll make some up here. That's okay. Thank you, though. Yeah, I'm okay.
I know you're sick. I wouldn't want you to use your brain power.
You're very compassionate, but I'll make it up. Let's hear f of x.
So what we could do is we could just find the domain for
Thir- thir-
f of x equals log
thir-
minus
13 plus 5 times the log base 2 of, let's say, I don't know, 2x plus 7. So that one's kind of a mess. So we can ask, let's ask ourselves the following questions. What's the domain of the function? And what's the range of the function? What's the formula for the inverse function? These are 3 questions I want to answer. So let me say that again. Domain of f, range, all right, formula for f inverse. All right, those are the questions. These are interrelated questions. Let's answer them. So let's actually start with the last question. Well, up to you guys. Do you want to answer the domain question or the inverse question? Either one of those we could do first. The range we should do last.
Domain.
Domain? All right, so you guys tell me, what's the domain? So x such that what?
Oh my God! Negative 2. Negative 2 positive infinity.
So what I want here, guys, is
Wait, and you sick too, right, Mr. Cody?
I am.
It's like Michael Jordan's flu game. Because you're just going crazy while you're sick. You just make everything
You're not helping my humility.
right.
I told you I was working on this. This is very insensitive of you. I'm triggered. I feel like these are medium-sized aggressions that you're making against me. You're invading my safe space. Whatever that means. Anyway, so what we need is we need the input for the logarithm to be positive, right? That's the name of the game here. So how do you achieve that? Well, how do you get 2x plus 7 positive? You need what? 2x greater than minus 7, which is x greater than minus 7 over 2, right? So we have what? Apparently minus 7 halves all the way on out to infinity. So there you go. There's your domain. So the domain of the logarithm, you just need to figure out what does it take to make the inputs to the logs all positive, right? It could be more complicated, right? Like you could have a function where you're feeding a quadratic into a logarithm and you'd have to solve a quadratic inequality to answer this question. That could happen. Let me focus on this problem. Yeah?
And if you have multiple logs in the question?
Then every input to every one of them has to be positive. So it's like, like we can look at one of those next. Let me finish this one here. So we then to find the inverse, we put y equals to the formula, which in this case is 13 plus 5 log base what? 2 of 2x plus 7, all right? Now my goal is to solve for x, right? Solve for x. So let's isolate that log, all right? So you want to isolate the log. Y minus 13 divided by 5 is equal to log base 2 of 2x plus 7. I did a couple steps at once there. Is that okay? I subtracted 13 to the other side, and then I divided by 5. Now my log is isolated. Now what do? Well, I can exponentiate both sides, yeah? So I have, and you got to pick a big font here, right? So I was telling one of you guys earlier, the mistake I see students make so much on this material is like you try to write everything in the same font. Like you got to make these things smaller than the base. Otherwise, you're going to lose track of what's being exponentiated versus what is, not being exponentiated. So like this, 2 to the that is 2 to the log base 2 of 2x plus 7. All right. And if for whatever reason I didn't give you enough space in the problem you're working, then like, say I'm working it on the back of the page. Work it on the back of the page and then put the answer there and say I worked it on the back of the page. Like I print these things out single-sided, so you can always go to the back of the page to expand your work if you need to, What's that? I print your test. The test, yeah. Oh yeah, well the mission, I can't stop you from making bad decisions. Let's see here. So 2 to the y minus 13 over 5 is equal to 2x. I mean, we have to be free to fail, otherwise we're not free, Freedom isn't always succeeding. If everyone's always succeeding, you're not really free. So x is equal to, like 2 to the y minus 13 over 5 minus 7 divided by 2. So there you go. Now that's we solved for x, right? What's the next step? So this is equal to the inverse function of y. There you, ow. So there you go. We found the formula for f inverse. Yay. It's not pretty, right? This one's pretty ugly. Question. Now here's the secret sauce. The thing that you need to know about that's like super useful. How would you find range of this function without finding the formula for the inverse? You'd have to graph it or like think about it, right? And you could do that, I guess. I don't want to. But the easier thing is that the range of a function is equal to the domain of the inverse function. See, in the domain of the inverse function, well, what is the domain of the inverse function? Yeah, it's all reals, right. Because this is an exponential. You can put whatever you want into it. It's fine. It doesn't care. Negative, positive, it's all good. So the domain is, yes, all real numbers. And so that, then, is in fact this. So there you go. We answered our question, all three parts. So one of you asked me about, what if we have a sum of logs? How do we figure out domain in that case? That's a good question. It's more subtle in that case. It depends. Log of x minus 2 plus the what?
Log of x minus 10.
X minus 10? You say x minus 10? Huh.
What's not? I was thinking about 106.
Oh, wait, never mind, I read mine. Just kidding, it's about 150.
Yeah, okay, fine. Okay, but I mean, we can, yeah, I mean, this is, well, there's natural logs in 106, right? It's the same problem. So what is needed here for this formula? The question of, listen, the question of domain is just the question of what x can I put into the formula such that the formula is well defined, that it makes sense, right? So what do we need? What do we require for the formula above to make sense? We need two things, right? What are the two things we need? Peace and love. Like the Nazis are on my doorstep. They're coming in. They're going to kill us all. What do you need? I need peace and love. No, I think you need a good defense. You know, you need to be ready for the hordes at the door. Anyway, listen, we need to make the inputs to the logarithm positive, right? So here there are two inputs to worry about. We need x minus 2 to be greater than 0, and we need x minus 10 to be greater than 0. So we need x to be greater than 2, and we need x to be greater than 10. You notice the and. So think about this. If you draw a number line, right? Here's 2, here's 10, right? If you're greater than 10, are you greater than 2? Right? Whatever, if you have any x over here, right? We automatically have 2 is less than 10 is less than x. So that says for this problem, the domain is what? Nope. Not 2 to infinity. Like for example, I can't put, if I try 6, I'm in trouble. See, because I have log of 4 plus log of minus 4. right? This is not allowed. So like f of 6 is, you know, it doesn't exist. So we have to start at 10. So we just do 10 to infinity, and the 2 doesn't even matter. What if instead of having x minus 10, I had 10 minus x? Hypothetical. What if I had 10 minus x instead of x minus 10? How would that change things? Just put a 10 minus x here instead. What would that change? That would take all of this, right, and replace it with 10 minus x greater than 0, right? Which is to say that 10 would have to be greater than x. So then all of a sudden, when you think about the number line, you got 2 here, you got 10 here, and you need x to be in between those two, right? In that case, the domain would be you know, 2 to 10, not inclusive, of course. And it's not hard to see that you could make a formula which just didn't have any domain, right? If I do, you know, x minus 10 and 2 minus x, then I need an x which is simultaneously larger than 10 and less than 2. And I could never achieve that.
Not even you?
No, not even me. Not in this course, anyway. No, well, yeah, in complex analysis, we can take natural logs of negative numbers. It's just that they take on an infinity of complex values, as was discovered by Euler in the 17th century. What's that? Oh, 18th century. I'm sorry, my bad. But so we have one more class, right? What should we do in the remaining class? I mean, yes, you have a quiz, right? What's that? Review. Review for the final sounds like a good idea. Hopefully I'll be not so sick by then.
On what to put on our page of notes.
Well, I should tell you what to put on your page of notes. How about you guys bring me your pages of notes and I look at them and grade them?
I don't like this. Actually, that's not a bad idea.
Yeah. How about you guys bring me your pages of notes? I pick the best one and then I copy it and give it to you all or something. I don't know. Somehow ideas which involve less work for the class somehow always win. Let's see here. Anyway, guys, have a good weekend.